Hi, my name is Alexander. In a previous video, we have created Angular front-end web application that uses SignalR library for real-time communication between servers and web applications. On the client side, we stored the orders data in the map object and transferred orders element of this object to the server side one by one in a loop. To optimize the data transfer, we will update the project to use the serialization of map object to transfer it as a whole to the server side by one transaction. Serialization is the process of converting an object or data structure into a format suitable for transfer or storage. Here's a diagram of data transfer from the Angular SignalR service method sendOrder to the server side. The total order object of map type contains the key-value pairs, where the key is laptop ID and value is a laptop's quantity. Using the for each loop, we transfer each key-value data and map object size value from the client side to the method sendOrder of the order hub class on the server side. It means that clients has to send as many requests to the server side as there are items in one order. The data from each request are inserted into the SQL Server database. In a case when order doesn't exist in the database, we also insert orders info into the orders table, but I didn't include this code in diagram for the simplicity. On the server side, we implement static counter total order size to count the total number of requests from the client side per one order. When the counter value is equal to map object size, it means that all the data from the order has been transferred and we send a request to the database to get orders detail in the laptop order view list object. This object is sent to the client function receive order. To optimize data transfer, we can use map object serialization to transfer it as a whole to the server side in order to use only one request to the server per order, and use for each loop only on the server side to insert data into the SQL Server database. In TypeScript or in JavaScript, JSON, JavaScript Object Notation, is the most commonly used format for serialization. However, JavaScript built-in JSON stringify method doesn't serialize map object directly. It returns an empty object. To properly serialize a map, we need to first convert it into a different structure that JSON stringify can handle. The new diagram reflects the updates. In the Angular SignalR service method sendOrder, we serialize map object. First line converts the map into an object using object from entries. Second line serializes the resulting object using JSON stringify. The stringified map object is sent to the method sendOrder of the order hub object. In this method, stringified object is deserialized into the dictionary object laptop order view, where keys and values are equal to the same keys and values of the map object on the client side. Using for each loop, the orders records from the laptop order view dictionary are inserted into the database. After that, we send a request to the database to get orders details in the laptop order view list object. This object is sent to the client function receive order. Let's implement the updates in the project. Open Angular project. In the sendOrder method of the SignalR code service class, remove for each loop for map object total object. Serialize the total object containing the orders details and send it to the server-side method sendOrder of the order hub object. Open server-side project. In the order hub class, remove static member total order size. In the sendOrder method, update method signature. Now it requires only three parameters: order ID, total order serialized, and is in group. Deserialize total order serialized string into the dictionary object. Use for each loop to insert the orders records from the laptop order view dictionary into the SQL database. Remove condition for the total order size. Now use serialization to transfer the orders data from the client application to the server-side application using only one request. Test application. Start client application. Start server-side application. Open client-side application in another browser, Firefox. Create order. The order is created. Connect to this order from Google Chrome browser and check Add to Group checkbox in both browsers. Add new items in Google Chrome browser. Send order. The order is updated in both browsers. Remove items in Firefox browser. Send order. The order's data are removed from both browsers. Check SQL Server. Order exists in both tables. Remove all items from the order. Send order. Check SQL Server. The order's data are removed from the tables. That's all what I wanted to show you in this video. If you are enjoying this content and would like to see more and support my channel, please feel free to like this video and hit the subscribe button. Thank you for watching, have a good day, and bye!